Welcome to the video for question 20 and 21. So question 20 asks us to fill out the table below for the different types of bonds. We have ionic and covalent bonds. It asks the types of elements involved with this type of bonding, what holds the atoms together, and what properties do these compounds have. So let's start with ionic. Ionic bonds are between metal and non-metal elements. What holds them together? Ionic forces and really it's an electrostatic force that holds the cation and the anion. So remember that a cation is a positive ion and an anion is a negative ion. Cat has a T. I like to think of that as the plus sign. An anion sounds like onions, and onions make me cry, and crying is bad. What properties do these compounds have? They are crystals. They have crystalline solids. They're brittle. So if you get a piece of salt, you can break it. They have very high melting points. That's why you've never seen melted salt at your house. They become electrolytes, and we would call them a salt. Just a regular salt, such as NaCl, which is my favorite example of an ionic compound. Then we have covalent. Covalent bonds occur between two or more nonmetals. And what holds the bonds, what holds the atoms together? The covalent bonds are held together by the sharing of electrons. Between two atoms. And what properties do they have? Well, they have very low melting points. They're non-electrolytes. And can have various forms and shapes. Question 21. Explain how the electrons move in a metallic bond and why they are considered good conductors of heat, electricity, malleable, and ductile. Well, you must remember that metallic bonds are between two or more metals, metal atoms, I suppose, be more proper. So metal atoms are very close together. They're actually so close that their electrons form a disassociated sea of electrons. So we have a sea of electrons. And the sea of electrons is between a lattice structure of cations. Remember, cations are the positive ions. So I have cations in a structure where around them we have electrons that are disassociated. Because the electrons are disassociated, they can move freely, and it is this free movement of electrons that allows for metals to be good conductors of heat and electricity. It allows them to be malleable and ductile. Because there's no real bond between them except an ionic-like bond, then when you rearrange the lattice, there's nothing to break because the cation is attracted to the sea of electrons all around it. That's why the sea of electrons with the disassociated electrons cause metals to be good conductors of heat, electricity, malleable, and ductile.